All right, in this video we're going to be talking about try, catch, and finally. Try, catch, and finally are three blocks that you can use to handle errors in the standard way that C# and in fact most languages have defined, which is the concept of an exception. So yeah, let's go ahead and see what the syntax looks like and see how you can catch errors. So under normal circumstances, if I were to cause an error to happen, and I'm just going to do something that is pointless, but just to prove a point, I'm going to do that.
Okay.
Or actually, let's just make resharper happy and do to upper. And so this is obviously
It's the most awesome code I've seen all week.
well, it's valid. This will throw an exception, and let's just run it to prove it. We have an exception. Now, the interesting thing about this exception is because we don't have any code inside of our program that is designed to handle any exceptions, it will bubble up all the way to the top of the process and crash your entire program. Literally, if I did not have a debugger running right now, you would get a nasty error. And a program X has stopped responding or is crashing or something to that effect. Now, the way to handle this is to use a try block and a corresponding catch block, or multiple catch blocks. We'll talk about that in a second. I don't want to do that. I just want to write this out myself. So I'm going to do that. And then I'm going to talk about this syntax. This syntax is we have a try block and a catch block. And the try block, everything inside of the try block will execute normally, as it would under normal circumstances, except for when it runs into an exception. And when it runs into an exception, what's going to happen is the runtime is going to unwind the stack, looking for a instance where you have code wrapped inside of a try block. Once it hits the try block that's closest to it. So, for example, if this was inside of a method, then this try block, and that method did not have a try block, this try block would be considered the one that it found. Then it starts to look at the corresponding catch blocks associated with this try block. And catch blocks are just the keyword catch directly under the last closing curly of the try block. Now, in this case, we have a catch block. This is called a general catch block. What it means is it will catch every single exception. If an exception is thrown and it is of any type, the code that will execute immediately after that exception will be inside of this block. So in here, I can write my own error handling. I could do logging. I could present a nice, pretty error to the user. I could do something else. I could try to correct the problem if I know beforehand how to correct it. Unfortunately, general catch blocks aren't all that useful, and the reason they're not that useful is that there's no way to understand or know the context of the exception that was thrown. And there are many types of exceptions in the in .NET. So a more specific way to catch an exception would be to catch with the type of the exception specified in the parentheses. Now, in this case, this is actually perfectly equivalent to this general catch block. But what I'm doing here is a bit different. I'm actually specifying the type of exception that we're going to catch. And because all exceptions inherit from the exception class, that means that this code will run regardless. So just to let you know, these two blocks are equivalent. In .NET 1, this was not the case. In .NET 1, if a exception was thrown outside of C#, so for example, a C++ exception was thrown and it was caught by C# code, this code would not execute in that case because that exception was not of type system.exception. This code would. However, in recent versions of the .NET framework, they have, whenever an unmanaged exception is thrown, it gets wrapped in what's called a wrapped exception. Runtime wrapped exception, sorry. So finally, we have so again, both of these are equally as worthless, but one is just one way to express the same idea, and the other one's the other way to express the idea. The third way to do it is to kind of give it a type that's actually lower on the inheritance hierarchy than the system.exception class. And in this case, this is the null reference exception. The null reference exception does inherit from exception, so therefore it is valid as a type specifier inside the catch block. And in this case, what will happen is we now have three catch blocks. Remember, these two are equivalent, this one is not. The way in which the CLR will invoke any of these catch blocks is to look at the type that we have specified and determining if this type is closer to the type of exception that was thrown than any other catch block above it. So this, or below it, sorry. So this one will execute in the case of a null reference exception, whereas this catch block will not execute in the case of a null reference exception. Just because we have specified a specific behavior to happen inside of this block.
Okay.
Finally, another interesting thing you can do with catch blocks is define an exception variable. So if I were to specify an identifier after this type this type usage, I can go ahead and give it identifier. So let's call this exception. Now we actually have access to the object that was thrown as the exception, and we can do things that we wouldn't normally be able to do, such as access the data property, which is very interesting, the inner exception, the stack trace, and the message, which are all very, very important properties. Mainly for debugging usage, you probably shouldn't show those to clients or customers. But the idea is that we can encode additional information inside of an exception when we throw it, and if we specify an identifier after the type inside of a catch block, that data is captured, and we can actually use that to make a more informed decision about how to correct whatever error happened. Now finally, nested try blocks are pretty common in C# because we'll often have call stacks that are varying various levels deep because of abstraction. So we kind of want to, in some cases, we will have a catch block that does some sort of cleanup or error correction, but still doesn't exactly know what to do with the exception that was thrown. It still doesn't know how to actually properly handle it and resume normal execution. So what we can do is we can specify a throw statement followed by a semicolon inside of any catch block. And what this will do is this will rethrow the exception that was thrown. So it allows us to just to sandwich in some of our own little catch logic, and then give execution up to the next person in line, as if the exception was just thrown and not caught.
Okay.
So that's pretty much it for catch blocks. They're very straightforward. You can return out of catch blocks, you can break out of catch blocks, you can continue out of catch blocks, and so on. But there's one more block in exception handling that is very, very important, and that's called the finally block. A finally block, you may only have one, and it is specified at the end of the catch blocks associated with the try. In addition, you may have a try block with a corresponding finally block without a catch block. So this syntax, while pointless in this case because I have no code, is perfectly valid code. What it finally allows us to do is, if execution is ever to leave this try block, this catch block, this catch block, or this catch block in any way, and that includes exceptions being thrown, the try block executing fine and not having any exceptions, a break statement or a go-to statement or a continue statement or a return statement in any of the try or catch blocks, if any of that is to ever happen, if the instruction pointer is ever to get anywhere outside of this, finally will execute. Finally happens whether or not, you can think, a simple way to think about it is you can think finally happens whether or not the exception is thrown. But in reality, finally is called whenever code execution leaves any of these constructs, regardless of how.
Mm-hmm.
And finally blocks are mainly used for disposing of resources that have to be disposed of regardless of whether or not your try execute, or your code and your try statement properly executed. So let's say we have a file that we open. We have an open handle to a file. We do some logic with the file, then we close it. If we were to not have any exception handling inside of that code, it is possible for an exception to be thrown in which will halt execution on that method and not close the file. Instead, if you were to put it in a finally block, the file.close, that is, you will ultimately close the file no matter how execution left that method.
Okay.
The limitations of finally is that you may only have one. You cannot return, break, go to, or continue out of a finally. And other than that, that's about it, really. If the last consideration of finally is that if you throw an exception inside of finally, the exception that might have been thrown previously is lost.
Okay.
So if I were to say, if I were to do this and let's just say that I throw another exception in here, I cause another error in some way, the exception that was thrown right here, the null reference exception, will ultimately be lost, and there's no way to get back to that data. So make sure that finally code is relatively bulletproof, because if it's not, if you're throwing exceptions inside of finally for whatever reason, due to errors in your code, you will lose valuable debugging information as to what actually caused the finally block to execute in the first place.
Gotcha.
And that's it.
Okay, cool. Well, with that is going to wrap this video up. Thanks a lot.